Hello everyone. So this tutorial uh, we will be discussing about transport layer protocols, particular UDP, user datagram protocol. So as we know, transport layer protocol is the heart of the TCP/IP protocol suite or OSI layer, right? So transport layer is suited uh, in between the application layer and the network layer, right? So the bottommost three layers, which means physical layer, data link layer, and network layer, will be implemented by hardware. So, whereas the top layers, right, application layer, presentation, session layers, right, in the case of OSI model, will be implemented by software. So, TCPI, sorry, transport layer is the interface between these two uh, uh, protocols, right? Application and software application, software layer and hardware layers, right? So that's why people used to call a transport layer as a liaison or uh, heart of the TCP/IP protocol suite. So there are three important protocols associated with transport layer. They are UDP, TCP, and SCTP. Right. So EDP stands for User Datagram Protocol, TCP Transmission Control Protocol, SCTP Stream Control Transmission Protocol, which is a combination of uh, both UDP and TCP. So in this tutorial, we will be discussing about UDP. So before getting to the protocol, uh, we should know what is port numbers, right? What are the uses of port numbers? See, transport layer, the main functionality of transport layer is to deliver the data packets from one process to another process, from sending process to receiving process, right? So, in order to accomplish this process to process communication or process to process delivery, uh, uh, we need uh, unique, right? Unique identifications to deliver the packets to the intended process, right? So in your laptop or desktop or mobile, right, there may be several application processes may be running at the same time, right? So at the same time, you may arise uh, more than one request, and you can also receive more than one messages at the same time. So uh, it is important to identify which process has requested for particular message and which process has received a message, right? So it is important to identify the correct process to deliver the packets, right? Uh, so for that we need a unique identification process, which is nothing but port numbers. So port numbers will provide end-to-end process, right? End-to-end address the transport layer and allow multiplexing and demultiplexing at this layer, right? So here I have used some of the well-known port numbers uh, associated with UDP and TCP protocols. See, port number 7 is for echo. So echo means that there is a connection between the source and destination, right? But 9 means discard the any datagram that has been received. 11 means active uses, how many active uses are there in the 13 is daytime, it will return the date and time of the server. 17 means quote, returns the quote of a day. So likewise, if there are some well-known port numbers, so maximum you can have 2 power 16 port numbers. That means 65,535 port numbers in a device, right? So, so with this, let's get started with UDP, User Datagram Protocol, right? So User Datagram Protocol is a very simple connectionless protocol, right? And it doesn't provide any error control, flow control, congestion control, right? Uh, it is assumed that the packet size is low, right? And there is no collision, right? There is no collision because it is using connectionless less service. So there is no need to establish any connection before transmitting the data. As soon as your data is ready, you can start transmitting the data, right? So it doesn't provide any error control, flow control. So it uses very minimal number of overheads to maintain the communication and services, right? There is less interaction between the sender and receiver. No retransmissions are allowed in the UDP, right? So this is the UDP datagram, right? So it consists of two components: header, UDP header, and UDP data, right? UDP header size is 8 bytes, right? 8 bytes, and those 8 bytes will be divided into 4 fields, right? 4 fields. They are source port number, destination port number, total length, checksum, and each field is of 16 bits in length, right? 16 bits in length, source port number, destination port number, 16 bits, total length of the header and checksum, right? So UDP packets are also called as user datagrams, right? And it has a fixed size of 8 bytes, right? So the UDP datagrams uh, will be varying from 8 bytes to 65,535 bytes. So if you don't add any data, the minimum size is 8 bytes. If you add any data, then the size will be varying from 8 bytes to 65,535 bytes. Right? So UDP header fixed size is 8 bytes. So source port number represents the uh, source host port number, right? So whenever a process is initiated, it has to acquire a port number from the operating system, right? Similarly, the destination port number will be used for transmitting the datagram. The length will indicate the overall length, which is calculated using this formula. UDP length is equal to IP length minus IP header length, right? So if you subtract IP length and IP headers length, the length of the UDP datagram will be calculated, right? The final one is checksum. Checksum is used to detect any errors during the transmission in the header, right? So here is a simple example of UDP header, which is given in the hexadecimal format. See the questions: what is the source port number, destination port number, total length? So you have to look at the first 4 digits because it is given in hexadecimal format. So first each 4 bit will represent the 16 uh, bits of the header field, right? The first 4 bits, first 4 hexadecimal digits represents the source port number. So you need to convert it into hexadecimal format notation, which means the value of source port number is 52,100, right? And the next 4 digits indicates the destination port number, which is equal to 13. Right? The next 4 digits will indicate the total length of the UDP packet as 28 bytes, and the length of the data is 28 minus header size 20 bytes, and the destination port number is 30, well-known port number, that is used to return the day and time of the server, right? So UDP services, see, UDP will provide process-to-process communication with the help of port numbers. And of course, you maybe heard of the word socket address. So socket address is a combination of IP address and port address. So when you bind IP address along with the port number, then the address is called as socket address, right? Socket address. And UDP is a connectionless services, right? It doesn't require any connection establishment and connection termination phases as like in TCP, right? It doesn't provide any error control, flow control. Only checksum will be uh, provider for UDP header, right? So in case any during transmission any error occurred in the header, checksum field will be used to intimate the receiver whether to accept the datagram or not, right? So how to calculate the checksum? See, here is an example. Um, all the user datagram fields will be converted to binary notation, and you have to do a uh, logical and operation, right? Logical and operation among all the binary notations, and the once complement of the final sum uh, will give you the checksum value, right? Will give you the checksum value, and you have to convert it back to hexadecimal notation and put it in the field checksum, right? So at the receiver side, the same thing will happen. If the checksum values all bits are zero, then the UDP datagram will be accepted. If it is not zero, all zeros, then the UDP datagram will be discarded, right? Discarded. So encapsulation and decapsulation. So the message UDP messages UDP datagrams are encapsulated within IP packets, right? IP packets, and the IP packets are encapsulated within the data frames, right? At the sender side, whereas at the receiver side, the reverse process decapsulation will take place, right? So this is how multiplexing and demultiplexing will be implemented in UDP, right? Uh, Queuing in UDP, see at the client side, whenever the process starts, it has to acquire the port number from the operating system, right? So there are two queues. One is for outgoing queue, another one is for incoming queue, right? Whenever you want the data to transfer, you have to transmit the, you have to transfer the uh, messages, datagrams to outgoing queue, right? And the UDP protocol will transfer one message at a time, one datagram at a time. Similarly, at the receiver side, the messages will be delivered to the incoming queue, and the UDP protocol will process the datagrams one by one. So this is how UDP communications will be implemented. So the applications of UDP used for simple request response communications. The best example is network time protocol, DNS, domain name service, network news protocol, right? Most of the real-time uh, streaming, right? Real-time streaming applications are using UDP because it doesn't require any error control, flow control, retransmissions, uh, and connection establishment determination. It is possible for uh, reconstructing the or missing or corrupting data, because for live streaming the latency should be very minimal, should be very minimal. So for real time streaming applications you can go for UDP, right? So UDP package consists of 5 components, right? Control block table, input queues, control block module, input module, output module, right? So the input module, output module is nothing but the memories, right? So the input incoming messages will be stored in the input module. Outgoing messages will be stored in the output module, right? The control block table uh, will consist of several components or parts like process ID, port number associated with the process ID, and the destination port number, right? Waiting time, right? How many processes will be in the queue? All those things will be maintained in the control block table, right? The control block module will uh, help the process to acquire the uh, port ID, right? Port number from the OS. So on behalf of the process, whenever the process is initiated, the control block module will try to communicate to the OS to fetch the port number for the particular process and ID, right? So, so finally, the UDP at a glance, UDP is a connectionless protocol and it doesn't provide any error control, flow control, and doesn't care about data integrity and reliability, right? And it can be vulnerable to denial of service attacks. So even a legitimate server, a legitimate user is trying to access a service, right? Sometimes uh, the service could be denied to the legitimate or legal users, right? So uh, the, that's all about the fundamentals of user datagram protocol, right? So in the next video, we'll talk about stream control transmission protocol because I've already uploaded the video about transmission control protocol. So you can have a look at the TCP. And if you have any questions, post it in the comment box. Thank you for watching.